Welcome back to another video. It's your favorite math professor here, Dr. Tarcia Hubert. And in this video, we are going to talk about how to calculate the standard deviation of discrete random variables. So we've been talking about discrete random variables. If you haven't, go back and watch the video about what exactly is a discrete random variable. It's basically a table of all of the possible values of x and its probability. The probability for each of those possible values of x, all right? So we talked about how to calculate the mean. Now we need to calculate the standard deviation. And so here is the formula for standard deviation. Now, there are two different formulas, and you can use either one. In this video, I am only going to use this second one right here, okay? But for the first formula, you would do x minus the mean of the discrete random variable x squared times the probability of x, all right? And you would do that for each data value, and then you will take the sum of those. Or the second formula is you will take each data value and square it and multiply it by its probability and take the sum of those and then subtract the mean square from it and then take the square root of it. Oh yeah, and I forgot to mention you take the square root of those at the top too. Again, I'm going to be using this second formula here. We're going to do the sum of x squared times the probability of x. And take the sum of all of those, and we're going to subtract the mean of x squared from it. Then take the square root of it, all right? So let's jump into an example. In the following probability distribution, the random variable x represents the number of marriages an individual aged 15 years or older has been involved in. We want to compute the standard deviation of the random variable x. I'm going to take this table, and I am going to put it into Excel. Again, if you're using my math lab for your homework, whenever the table presents itself, there is an option for you to click the table in Excel and it will transfer it automatically for you. I recommend that you do that and you don't type it so that you won't have an error of a possible error of entering in one of those numbers wrong. So I'm going to go over to Excel and we're going to calculate the standard deviation. All right, I'm in Excel and what I have here is the table in my A and B. I have my x values, my possible random variable values, and I have my probability of x for each of those. First thing I want to do is calculate the mean, and the mean is pretty simple. Remember, you just take x times the probability of x, and then you add up all of those to get the mean. So here I'm going to hit equal, and I'm going to do this first cell times this second cell right here, and I'm going to hit enter. I'm going to click on that cell, click in the corner, and drag it down so it can apply that formula to each of these. And then here, I just want the sum of all of these x times p of x, and that will give me my mean. So I'm going to take the sum, open parentheses. I'm going to scroll and drag on those cells I want to add up, close parentheses, and hit enter. And this is our mean, which is 0.919. Now, if you recall, the formula had a mean squared in it. So I'm going to go ahead and square the mean, and I'm going to do that. I'm going to hit equal. I'm going to do the mean times itself, the mean. That's what mean squared is. All right, and that gives me my mean squared. I'm just getting it ready and set up to plug into the standard deviation formula. All right, next thing I need to know is what is x squared, because in the formula we have to do each x squared times the probability of x. So I'm going to do x squared first. So here I'm going to hit equal. Here's my x, and I'm going to multiply it by itself since it's squared. And hit enter. I'm going to click this cell and drag it down, and that's going to square each of those x's. Now I want to take each x squared and multiply it by its probability. So I'm going to click here for x squared, do my times symbol, and then times the probability here and hit enter. And I want to apply that formula to each of these, so I'm going to drag this down and it applies that formula to each of those, all right? Now in my formula, I had to take the sum in my formula for standard deviation. If I need to go back to it, I will. Hold on. All right, I'm bringing you back to the formula. So remember, I wanted to take each x squared multiplied by each probability. And that's what we've done so far. Now I need to take the sum of all of those. Once I take the sum of all of those, I'm going to subtract the mean square from it. Once I do that, I'm going to take the square root of it. Okay, so now let's go back to Excel. So here are my x squared times p of x, and I need the sum of those. So equal sum, open parentheses. I'm going to scroll this down, and that's going to give me the sum, 1.391. And remember, now I want to do the sum of those minus the mean square. So this, for my standard deviation, is going to be the square equal to the square root, which is you're going to type in SQRT for square root, double click it. And you want to take the square root of the sum of those x squared times p of x's minus the mean square, which is what we calculated here. Close parentheses and hit enter. And that gives you your standard deviation, which is 0.739. If you round it to 2 decimal places, 0.74. 0.74 is your standard deviation, all right? So we actually went through the formula. We did calculate it by hand, but we used the calculator in Excel to do it. So we actually went through each step to calculate the standard deviation by hand, all right? So something else that problem like this could ask you is, what is the probability that a randomly selected individual 15 years or older was involved in 2 marriages? That's just basically looking at the probability distribution and figuring out what is the probability for 2. It would be 0.121. So I'm going to write 0.121 here. And I might have wrote that too big because I do have another one more part I want to add. So 0.121 will be the probability for part A. Delete it so it won't get in the way. All right, and then the second part will be, what is the probability that a randomly selected individual 15 years or older was involved in at least 2 marriages? So this one was involved in exactly 2. This one is in at least 2. At least 2 means it's 2, 3, 4, or 5. So we want to know, what is the probability of 2, 3, 4, or 5? So I'm going to write that out here. Probability of 2 or 3 or 4 or 5. Well, remember what OR probabilities mean. And if they are disjoint, how do you deal with them? Well, OR probabilities mean you add the probabilities. And if they're not disjoint, then you would subtract out the overlapping portion. But in this case, each of these events are disjoint, or basically because having 2 kids and 3 kids is not the same, and there's no overlapping between that. So you will take the probability of 2, which is 0.121, plus the probability of 3, which is 0.027, plus the probability of 4, which is 0.004, plus the probability of 5, which is 0.001. And add those together, and you get a total of 0.153. So the probability that a randomly selected individual 15 years or older was involved in at least 2 marriages is 0.153. And if it helps you to look at that as a percentage, that's approximately 15%. All right? And so this is how you calculate the standard deviation, and we also answer a couple more questions about this probability distribution. If you have any questions whatsoever about this problem, please don't hesitate to reach out to me and let me know what your question is. You can email me or you can comment on this video. Thank you for watching, and I will see you in the next video.